Did you start record?
Yes. Yeah, now I start record.
Good time of the day, everyone, and welcome to the new episode of EPIC Members' new product release. We're now in June 2025, and we will update you with the most recent achievements of our EPIC members. Let me remind you first that EPIC is the largest photonic industry association in the world that includes over 800 corporate members. And today we have an update from 6 of our members, all very exciting topics. And just to list them briefly, we'll see something from Chilas BV, from Arden Photonics, from AIXEMTEC and Coherent, as well as Delta Optical Thin Film and Femtum. And without further delay, I'd like to introduce our first speaker, who is Jan van der Vlekkert, Business Development Manager from Chilas. And he will introduce Atlas, wavelength tunable, Comet, swept source, Polaris, frequency stabilized lasers. Welcome, Jan.
Thank you. I'll share now.
Whenever you're ready, you can share your slides and the floor will be yours.
Yes. All right. Thank you, Ivan, for the introduction. I'm Ian van der Vlekkert. I'm Business Development Manager at Chilas. And today we'll talk about the new 3 products that we released the end of last year and the beginning of this year. And let's get right into it. So Chilas at a glance. Chilas was founded in 2018 as a spin-off of Lionics International, where we commercialized the silicon nitride triplex platform of Lionics and turned it into a full-blown laser, a tunable laser. In 2020, we launched our first product, tunable laser at 50-50 nanometers, complete with electronic drivers. But this was more as an initial product to showcase what the laser is capable of. Well, 4 years later, we have fully integrated it into a hybrid laser module. We have multiple distributors all over the world, and we established a supply chain for chips, assembly, and packaging of the electronics. So we have a nice and stable connection throughout. That gets us to 2025, where we have high-performing tunable laser modules, where I will dive into now. So a bit of background to the technology. Here you can see the hybrid integrated external cavity laser, where we here on the right see the silicon nitride feedback chip, which incorporates 2 microring resonators, which we use to tune the laser over a wide range. Both of these rings have a slightly different FSR, so we can hit all the wavelengths in between of the wavelength range. Due to the silicon nitride waveguide circuit, we have extremely low line widths, and we have high output powers due to the semiconductor optical amplifier of choice that we use. For example, for 1550, use indium phosphide, and if we go low, we can go for InGaAs or any other material. How it started is just with the butterfly package laser, and to showcase what the capabilities were of the laser, we put it into an evaluation electronic driver, a big bulky one, which was more for use to test the laser, put it inside of your own lab equipment, where you could switch out the current drive or the temperature control to test the laser and maybe incorporate it into your own device. But what we really wanted to do is showcase what the laser is all possible of, and made our own electronic drivers, including current driver, heater driver, tech controller, and everything in it, inside of a package the size of a cigarette package, nice and compact, where we showcase what the laser can do. So this is our current product line. We have the Chilas Atlas, which is a wavelength tunable laser, the Chilas Comet, which is the swept source laser, and the Chilas Polaris, which is a frequency stabilized laser, which only serves 1 wavelength. To go into the Chilas Atlas, a wavelength tunable laser. We provide the module with the software, with the graphical user interface, to which the user can tune the laser to whatever wavelength they want, which is within the wavelength range that we provided within on about 10 picometer accuracy. What we offer is already 1550, which is our first line, but we also offer it at 1600 nanometers, 1700 nanometers, 850 nanometers, and 685 nanometers coming this September. As you can see, the wavelength ranges are broad. We have a grid of very short wavelengths. And there's also the ability to tune the wavelength even finer to the modulation input, which allows us to have a bandwidth of about 500 kilohertz. Well, if this is not enough, the Chilas Atlas, if you need more capabilities of the laser, for example, sweeping or scanning, then we come out with our Comet, which is a swept source laser, which can be used for, as I said, fast scanning of the wavelength. As you can see here, we have a nice linear sweep over the full wavelength range. Over large ranges, we have a rep rate of around 1 to 2 hertz. But if we go to smaller ranges, so if we can scan subsections of it, we can achieve much faster sweep rates of around 1 kilohertz at a range of about 30 to 25 gigahertz. The Comet, as I would like to say, is always a Swiss Army knife, which can be used for every application there is. Let's say OFDR, LiDAR, or even OCT. And because of its versatility, it can be used in every lab environment as well. This is how we then deliver the laser. We deliver the laser normally with a DE9 pin connector, as you can see here. But to make it more handy of use, we also deliver with the Comet adapter or with an Atlas adapter, which allows the user to use it with a USB connection and have trigger input signals as well as a normal on and off button. Then the third product that we released this year is the Chilas Polaris, which is just a frequency stabilized laser, which excels in very low phase noise, excellent stability, and has an excellent integral line width measured at 10 milliseconds. This laser is perfect for applications that just need one single wavelength that is stable all around, like DAS applications, for example. And this is some of the applications that we serve as Chilas, like spectroscopy, sensing, quantum key distribution, optical device testing, terahertz generation, LiDAR, and even more. The applications are endless, and it's really hard to name all of them. And yeah, the lasers fit in with a lot of niches as well. So if you're ready to tune in together, you can reach out to info@chilas.com or fill out our contact form or message me directly, and we'll have a talk about our nice products.
Thank you, Ian. Is that all you have for today?
Yeah.
Perfect. Okay. Thank you very much. Great presentation. Large variety of products that Chilas can offer right now. So yeah, just to remind everyone in the audience now, so we have after each talk, 1 or 2 minutes for a short Q&A session. So if you have any questions for our speaker, please push the raise hand button at the bottom of your Zoom screen, and I pass you the word. So you're all very welcome to ask you quick questions. Otherwise, I'm also happy to put you in contact with our speakers after the meeting. So now, so please go ahead if you have any questions for Ian. In the meantime, I'll ask Ian. So what are the bestsellers of Chilas BV? And maybe some highlights.
The bestsellers of Chilas BV, our current bestseller is the Atlas 5050 100 nanometer version, which tunes over full 100 nanometers encompassing the SC and L band. Which is already used all over the world and is one of our best sellers this year. Yes.
And another question is, so how much of quantum applications you recently see among the demands that you receive?
How many? Well, that depends. So the next thing that we will bring out is in September is the Atlas 685, which is in the visible wavelength range, which is much more to do with quantum applications. So we already have some requests for that laser as well. Furthermore, for quantum, I think it's around 10 to 15% of the requests come in for quantum applications.
Okay, let me pass the word to Kit from Arden Photonics. Go ahead, Kit.
Hiya. So we have a potential application for a tunable wavelength laser around 1060 nanometers. Is that something that you're looking at developing?
Yeah, we're currently in 2 development projects even, one for the O band and one for 1060. The O band will be ready around September, August. And for 1060, we're now in the starting development phase. So it would be very handy if you could send me the exact requirements that you have for the laser that you have in mind. So we can still take it into our fabrication process, because we're now going to get started on designing of the feedback chips.
Okay, yeah, that'd be pretty useful.
So,
Thank
but
you.
I would think then that's around 8 months for the first prototypes away.
Yeah.
But if we have your specifications there, then we can already incorporate it maybe.
Yeah, sounds
Okay,
very
there
good.
is
Thank you.
also, thank you, Kit. There's also a quick question in the chat. So Javier from SIA is asking, how is the frequency stabilized?
That is through on-chip technology, and I can't disclose anything about the Polaris for now. If you want to have more technical information about that, we can set up a meeting and set up an NDA or some kind.
Okay, I hope that answers your question, Javier. Okay, so thank you very much again, Ian. Let's pass to the next speaker. The
Yes,
second
thank you.
speaker today is Kit Buchanan, the senior design engineer from Arden Photonics, and Kit will
Yes.
produce their FGC array.
Hiya, guys.
Whenever you're ready.
I'll just get my screen shared, and then we can take a look. Okay, so yeah, hi everyone. My name is Kit Buchanan. I'm a senior design engineer at Arden Photonics, and today I'm going to be talking to you about our recently launched FGC array measurement system, which is designed to accurately measure fiber array units, also known as FAUs. So a little bit about ourselves at Arden Photonics. So we design and manufacture measurement equipment here in the UK for customers all around the world. And we believe we are one of the only specialty fiber measurement specialists. So we look at hollow core fiber, PM fiber, multi-core fiber, amongst many others. So yeah, we aim to cover many measurement challenges that our customers face, and our expertise extends to fiber geometry, refractive index profile measurements, encircled flux, and others. So today, however, I'm going to be talking about a new product designed to measure the geometry of fiber arrays. So this product builds on our experience of measuring the geometry of single fibers with our FGC range of products. So for anyone unfamiliar with fiber array units, there's the image on the top right of a typical FAU. So basically 1D or 2D arrays of fibers that are spaced often around 127 or 250 microns apart from each other. So typical FAUs can have numbers of fibers anywhere from sort of 2, 3, 4 up to maybe even 100 fibers in a row. These fibers, or these FAUs, sorry, are typically on the end of bundles or ribbons of fibers, and just often used to help couple the light from these fibers into or out of arrays of waveguides or even photonic integrated circuits. So our FGC array is capable of measuring fiber arrays for both. Oops, wrong thing there. Where was I? Yeah, so we can measure these fiber arrays in both R&D and production settings. So we pinpoint core locations with accuracy up to 0.25 microns. This basically helps manufacturers and customers ensure the best coupling between components with the minimal loss of light. So the unit itself has a fairly small benchtop footprint of 450 millimeters square. We've got configurable external illumination boxes to help meet the needs of all our different customers. So as we've briefly went over, fiber arrays have numerous uses in industry. So it extends to sort of sensing, telecoms networks, data centers, photonic integrated circuits or PICs, along with the sort of medical and bioscience industries. So here we've got an image of a typical fiber array. The fibers are spaced 127 microns apart in V-grooves and then epoxied in place. And the front surface is polished flat. And that's what we're looking at there, the fibers in the V-grooves. And beneath that is the image of the illuminated cores. So the FGC array scans across the surface of the FAU, illuminating those cores, and it can measure FAUs up to 22 millimeters wide. So in addition to single and multi-mode fibers, we can also illuminate PM fiber stress rods and assess their angle relative to the array baseline. So that's another sort of essential measurement for customers to make sure that the PM fiber stress rods have been aligned correctly and will match up between two manufactured components. So our external illumination boxes allow for flexible core illumination at 630 nanometers. The system is designed to illuminate the cores with a consistent sort of symmetrical fill, which we've found through testing is needed for the most accurate measurements. So we have currently designed options for MTP and FC connectors, and we're looking at developing systems for bare ribbon fibers and other connector types. So the high accuracy translation stage is the key basically to achieving the core position accuracy that we need for our customers. We use a laser interferometer as part of our sort of factory calibration process, basically to characterize the translation stage in both the X and the Y axes for minimal error. Meanwhile, the optical system has been refined to ensure the best results possible. So we have a large field of view of 1100 by 800 microns, which allows for a quick and easy setup and focus. So basically we try and ensure that all sort of fiber arrays of all different shapes and sizes are easily visible on screen. We can then zoom into the correct region of interest and get the measurement going. So image distortion, again, as part of our calibration process, is assessed and removed, resulting in the most even and sharp images possible. When it comes to fiber handling, we've done a great deal of work to come up with a versatile and adaptable system. So we use a 32 millimeter wide adjustable array holder that's capable of managing fiber arrays that are ranging from 2.5 to 22 millimeters wide. And our system also has a tiltable mount, which allows the front end face of the FAU to be tilted by up to plus or minus 8 degrees. So we believe this sort of covers the vast majority of FAUs that we've seen, but we also have the ability to basically design custom fixtures for specific FAUs if required. So a little bit about the software. So this is a brand new software suite that we've designed for the FGC array. We developed it to allow for quick measurements using an adaptable array template system. So that's a template system that allows the user to specify things like the length of the array, the spacing and the fiber type. But as well as being quick, we've also tried to allow the user to do deep insights into the data and results. So allowing people to really drill down into individual measurements of the fibers, see what is going right with their fiber array, but also if something's going wrong, they can get an idea of that as quickly as possible. So measurements are typically very fast. We're looking at a few seconds per core, which obviously matters greatly for when you've got arrays of up to 100 cores wide. And then plus there's additional time for the sort of the setup and the focusing at the start of each measurement. But we've got that down so that arrays of up to sort of 8 fibers complete in less than a minute. And the software has been designed to be suitable for not only R&D and laboratory use, but also for production environments where we can save full data sets for later analysis. The system can be controlled externally through APIs. So we'll be demonstrating the FGC array itself at the Laser World of Photonics in a few weeks' time in Munich, alongside our MPA 600 refractive impact profiler, which we introduced on through EPIC a few years ago. Just some contact details here. If you've got some questions at a later date pertaining to the FGC array or any of our other products. And that's Rob there, who's our business development manager, who will be in contact. Okay, thank you.
Okay, thank you very much, Kit. Nice presentation. Now we have a minute or two for questions. So please raise your hands if you have a question for Kit. In the meantime, yeah, maybe I ask a little bit, Kit. So what's the way you distribute the products, especially inside Europe and also outside Europe?
So it depends on our products. We have distributors in various companies or in various countries around the world, but we can also deal direct if customers come to us.
Okay, so direct sales are also possible.
Mm-hmm.
All right. Any other special products coming out soon from Arden?
Not currently. We're looking at a few different ideas in the works at the moment, but yeah, the FGC array has taken up a lot of our development time recently, so we're really excited about not just releasing the product, but also being able to work with customers to improve it and overcome some of their sort of custom challenges that might occur.
Okay, custom works. Good. Okay, thank you, Kit, again for your presentation. Let's switch to the next speaker. So we seem to be missing Tobias Müller from AIXEMTEC. So we jump over this one and we go directly to the presentation of Coherent. And Dr. Florian Lenhardt, the product line manager from Coherent, will talk about more power and expanded wavelength range.
Okay, 1 second. Let me just get to the actual slide. So, okay, great.
All yours.
Thank you for the kind introduction and hello to everyone in the audience. My name is Florian Lenhardt and I'm the product line manager for all fiber coupled high power diode laser components produced at Coherent. I'm located at our mine site, which was formerly known as Chilas Diode Laser. Today, I'm excited to share with you the latest developments in one of our most important product lines, the Vector series of pump modules. Before we dive into the technical details, let me briefly introduce Coherent. Founded in 1971, Coherent has grown into a global leader in photonics with approximately 26,000 employees worldwide. In fiscal year 24, we generated $4.7 billion in revenue, serving a $64 billion market, and with 126 locations across 24 countries, Coherent is a truly global company with driving innovation across materials, components, subsystems, and systems. The Vector series consists of fiber-coupled diode laser modules based on single emitter diodes. These modules are available at key pump wavelengths 793, 808, around 880, and across the 9XX nanometer range. There are four main variants in the series, differentiated by the number of emitters included. The top two modules are Vector 1 and 4, covering the lower power levels up to 9 and 40 watts. These were formerly known as BMUs from Legacy 2.6 product line and have now been integrated into the Mines Vector family. And our focus today is on the bottom two, the Vector 16 and Vector 22, both developed in Mines. Vector 16 couples up to 16 emitters into 100 micron fiber, while Vector 22 supports up to 22 emitters and is typically paired with a 200 micron fiber for maximum power output. The key strength of the Vector series is our VBG stabilized technology. VBG, or volume break rating, is an optical element that stabilizes the diode spectrum and narrows its spectral width. Thanks to our in-house VBG supply via former ONDEX and advanced module design, we have achieved outstanding logging performance that can be seen in this slide that shows the logging map for a 976 nanometer Vector 22 module. And it's tested across a range of currents and temperature values. Blue area represents perfect logging, over 95% of power within the locked spectral band. On the left side, we highlight only the boundary points, those marking the lower and upper limits of the logging range, and notably no significant side peaks were observed. The key takeaway is that active temperature control is not required to maintain perfect logging. It was a wide power or temperature range. For instance, at operating currents between 15 and 20 amps, logging is maintained over 30 degrees C temperature span. At a cooling temperature of 35 degrees C, logging is achieved across the entire power range. And by selecting diode chips with different cold wavelengths, we can shift the locking range to suit specific needs. Beam quality at the fiber output is another critical factor, especially for pump applications. For end pumping, the spatial beam distribution is key. For fiber laser pumping, it's the angular distribution on numerical aperture. Our sophisticated design ensures a near flat-top beam profile and low NA, optimizing both spatial and angular performance at the same time. And we measure the NA using a high-resolution CCD camera and analyze the far field profile to calculate power content within a defined aperture. And this test is performed on every module built in Mainz, ensuring consistent, high-quality output for fiber laser pumping. Beyond performance, the Vector series offers several strategic advantages. We have fully vertical integration, meaning all critical components are developed and manufactured in-house Coherent. Our production is fully automated for Vector 16 and 22, enabling fast ramp-up for large-scale projects. We also offer a high degree of customization, provided the business case supports it. Our Swiss-made chips are known for their reliability, and our robust mechanical and optical design ensures stable, efficient performance. Every module undergoes extensive testing before shipment. And of course, all of this is backed by Coherent's decades of experience and reputation as a trusted long-term partner in the photonics industry. After covering the basic design and strength of the Vector series, let's change our focus to our new releases. During Laser Show in Munich this month, we will release our first Vector high-power module at 793 nanometer for Thorium fiber laser pumping. This new module is built in the Vector 22 package and coupled into a 200 micron fiber. It delivers 200 watts CW or 300 watts QCW. This makes it ideal for pumping medical lasers with high peak power requirements. For example, a 500 watt peak power Thorium laser would typically require 4 of these pump modules. The module features a fixed fiber with a pigtail output, and it includes a back reflection filter specifically adapted for the 1.9 to 2.1 micron wavelength range of the Thorium fiber laser. At Photonics Best earlier this year, we introduced our latest generation of pump modules for the 88X nanometer range. 88X nanometer in that case means 878.6, 885, and 888 nanometers for pumping neodymium vanadate or YAG. These modules are VPG stabilized, delivering a spectral width of less than 1 nanometer. We offer two power levels. Vector 16 delivers 150 watts. Vector 22 reaches up to 220 watts. Both use a 200 micron SMA fiber output, ideal for end pumping, and each module includes back reflection filter for 1060 4 nanometer laser light. Our next generation of VPG stabilized 976 nanometer pump modules for defense applications is set to also launch this month at Laser Munich. In this context, defense means more than just application. It also refers to the way these modules are engineered. The power ratings are intentionally overrated, and the modules did undergo harsh environmental testing, allowing the modules to operate reliably under demanding conditions while still qualifying for a minimum of 1,000 operating hours. We offer 2 variants. So Vector 16 module delivers 150 watts and features 100 micron fiber coupling. Vector 22 provides up to 400 watts with 200 micron fiber coupling. Both versions are designed to support different pump architectures used in high power fiber amplifiers. And once again, both modules come equipped with back reflection filters to block fiber laser light around 1050 nanometers. To wrap up, here's again the summary table of the entire Vector series. It consolidates all the key specifications we've discussed: wavelengths, power levels, fiber types, and more. And just as a reminder, while this table shows our standard offerings, we are always open to customized solutions. If there's a strong business case, we can absolutely discuss adapting a module to meet specific requirements. And last but not least, I'd like to also highlight that Coherent will be exhibiting at this year's Laser World of Photonics in Munich. We are excited to showcase our latest innovations, including the newly released Vector modules, which will be on display at our booth in Hall B3, booth number 317. If you're planning to attend, I'd be happy to arrange a personal meeting to discuss your specific application needs or answer any question in more detail. Please feel free to reach out to me directly to schedule a time. With that, thank you all for your attention, and I'm now happy to take any questions you may have.
Okay, thank you very much, Florian. Great presentation. Indeed, looking forward to see those products at the Laser World of Photonics in Munich soon. So please raise your hands if you have any quick questions. In the meantime, I'll ask Florian about temperature range for these lasers. What's the guaranteed temperature range which you can operate?
I mean, typically the operating temperature range means cooling temperature is between 20 and 30 degrees C, but we can go over that limits if required and can discuss that. Yeah. But of course, efficiency will drop.
Is the wavelengths also very much temperature dependent?
For the VPG stabilized modules, that's actually the feature. They are not depending on the temperature, as shown in this one slide. For the non-locked modules, it's about 0.3 nanometer per Kelvin.
Okay, I see. All right, so if there is no further question, then we thank Florian again. Looking forward to meeting in Munich and see the portfolio of Coherent products. And we switch to our next speaker, Poul Svensgaard, who is the CEO of Delta Optical Thin Film. Poul will talk about part-enabled breakthroughs in advanced optical filter design. Welcome, Poul.
Thank you so much, Ivan. I will just share my slides here. I think you can see my screen now. Can you confirm that you can see my screen?
Yeah, the floor is yours.
Okay, very good. So hello, everybody, and thank you for this opportunity to show you a little bit about what's going on here at Delta Optical Thin Film. Before I head into the product news, I would like to start just by giving a quick overview of our company. Delta Optical Thin Film has been around since the 70s and has always been an OEM manufacturer. So we make custom products. And basically, 3 out of 4 things that I'm going to show you today are examples of products that we have made for customers. And we launched them as news as such. And the last one is a teaser, is a more broad presentation of something that we're going to launch through the Laser World of Photonics. As you can see, we're a Danish company. We are located just north of Copenhagen in a small town called Hørsholm. We are quite well known for our continuous variable filters, or linear variable filters, as they are also known. Our factory, where we do things, where we develop and manufacture everything we deliver, is running 24/5. Codings take a long time, so we need to run in 3 shifts here. Okay, but let's go straight into the developments that we have launched here. The first product category I would like to present is made for advanced fluorescence setups, where OD6 blocking, out-of-band blocking has been the norm so far, but cameras getting more sensitive. Many of our clients are starting to look for better blocking, very close to the band itself. And as you can see on this graph here, this is an ordinary bandpass filter with very high transmission, very steep edges. But the unique thing here is basically that we block a lot better than typically OD6 here. It's above the band. This is an excitation filter. So you can see typically better than 12 orders of magnitude, which is quite dramatic. This does not come by itself, and this comes as a result of a lot of layers in the filter. Of course, the ability to design it, but also the ability to measure it, which is not trivial. And actually, this is measured by Institut Fresnel in France. We're not able to measure them ourselves right now, but we can design them and manufacture them. You will not obtain something like this without having 100% collimation of light. So if you know a little bit about optical filters, you know that this is not something that can be achieved in any setup as well. So it might not be relevant, but for those of you who are needing really advanced filters with very high out-of-band blocking, this is something we can do. We have quite a few of these already on stock. This is just one example. You can find more on our website. But if you need something like this, you can also talk to us. give us a call. We'll be happy to talk about it. So this is the first product example, and the next one I would like to pass on to you is actually two products. Up here on the first row, we have a multi-bandpass filter, a quad band filter here, also in this case made for fluorescence applications, where you have 4 LEDs that are multiplexed, and you have this excitation filter used, so it will pass all the light from the 4 LEDs. Over here you see the blocking. This is the same result, the same curve, just shown on a logarithmic scale. So you can see that we have excellent out-of-band blocking also for this filter. And together with this filter, we have designed a quad band splitter, which is a beam splitter for 45 degrees, which is shown here, sorry, on the lower graph. Sorry, I'm flipping around here. So this is also a very nice product that requires quite a bit of design capability and also manufacturing capability to make such a splitter for 45 degrees. And you can see here virtually no polarization split with the in the bands, and the bands are actually aligned with the bands for the excitation filter. So these are designed for the same system here, and is going into a light source for fluorescence applications from one of our customers. Yeah, also to be found on our website. All right, let me go on to the third example, which is a new category of beam splitters. This graph is actually showing the same two beam splitters here with different resolutions. So here you see a beam splitter for 446 nanometers. It's a dichroic beam splitter intended for 45 degrees of use. Very high transmission in a very high broad band. Excellent out-of-band blocking, quite steep edge. And if you look here, you can see our old generation of beam splitters. They used to have something like this of steepness here, where the new one, please be reminded that this is a very high resolution scale with only 20 nanometers from one end to the other here. So the steep one that you look at on the left side here, the black curve on the left, is actually the same as the blue one here. So you can see we have been able to put in a lot more layers in the design, and therefore increasing the steepness, which is ideal for separation of light sources, but also for instance, for combiners. If you want to combine multiple LEDs into one light source, this kind of technology is extremely useful. Could also be lasers, of course. Okay, so this is the three specific examples I've taken out today. We also have a lot of new other stuff, nudges, astronomical filters with multiband, but we can't cover that all today here. So if you're interested in that, you'll have to come and see us at the Laser World of Photonics. The last example is not an example at all, but we, as you might be able to read here in the background, we are actually breaking ground now with our variable filters, our variable filter category. We are just introducing a complete new way of manufacturing these that will allow us to say yes to things that we have not yet been saying yes to. So you can imagine that we will be covering a much larger wavelength range. So we will have better auto sorting filters, we'll have better edge filters and also bandpass filters for the time to come. We are very interested in discussing with you what your needs are, and we will be showing the first examples at the Laser World of Photonics, but this is a little bit premature, so I'm not able to show any curves yet. So that's why there's only this teaser here. And we hope to see you in Munich and discuss with you if you are interested in our variable filter technology. I think that's going to be all I'm going to say today. So thanks for your attention. If there are any questions, please let me know.
Okay, thank you very much, Poul. Indeed, looking forward to see you all in Munich and to see the new product from Delta there. if there is any question, please push the raise hand button. And in the meantime, I was wondering, Paul, yeah, so 10 levels of magnitude and transmission, indeed, is very impressive filtering. I was wondering at which scale can you make those filters? Like, what's the largest surface area and the smallest surface area you can offer?
Well, if you're talking variable filters or filters in general?
Variable filter.
Well, variable filters can be made from the length of maybe 20 millimeters up to 120 millimeters. That's what we currently have been offering. But if there are customers who would like to challenge us on that, I mean, that's how we develop. That is typically by being challenged by customers and getting into a dialogue about your needs. So we have said no to very short filters until now, but this is something that we're definitely going to take up again.
All right. Well, thank you. Exciting. Okay, if there is no further questions, let's thank Paul again, and we go to the last speaker of our session today, who is Robert Baribault, the principal solution architect from Femtum. Hello, Robert.
Hello.
And, Robert will talk about Photonics wafer laser trimming solution.
Exactly. So first of all, while I'm sharing my screen, I want to say thank you for the opportunity to share and speak today. I think it's a very nice opportunity. So are you seeing my screen right now?
Yes, the floor is yours.
Perfect. To share.
Yeah, all good.
Okay. You're still seeing my face, right?
Yeah. Also.
I apologize for the delay.
No worries, no worries. Yeah. Okay, now it's good.
Now it's good?
Yes.
Okay, perfect. So thank you for being this. I'm Robert. My name is Robert Baribault. I'm principal architect, principal solution architect here at Femtum. Today we're going to talk about laser trimming of photonic circuits. Really a quick history of the company. The company was founded in 2017 by two Laval University students based on the short pulse 3-micron technology. And today we've branched out and developed applications for semiconductor and photonic integrated circuits, cleaning and trimming. We have fully equipped test labs. It's a complete solution from hardware to software. It's fully integratable into the semiconductor machines. So basically, the reason we're here is because Femtum is because the silicon photonic market is increasing. I'm not going to go. This is just one of the many forward-looking statements. The annual growth rate is very high. So basically, after a long wait of the silicon photonics, we know that the silicon photonics is now market of today. So let's just see what the market brings with this. So basically, since we're manufacturing photonic circuits, the photonic circuits themselves are more difficult to manufacture. Their process variations affect the spectral response in various ways. One of the reasons why this is the case is that the parameters, the work parameters or propagation parameters for the waveguides depends on the physical dimensions of the waveguide itself. So for some, this is a couple of 100 nanometer wide. So it's very difficult to be able to manufacture these. So what kind of situation are we looking at? If we're looking at a micro example here, at the wafer level, you see that the spectrum is variable, and the actual spectral response depends on the position on the wafer. So we have some kind of distribution of the resonances, which are the dips in the peaks here. So let's just take a moment to look a bit more into the details of this distribution and how it affects performance. So you have some basic three categories, so the pass or A grade, which are around the central design wavelength. Some are really, really way far out and are offset. And depending on what the commercial value is and what you want to do, the outliers might be B grades or might be fails. So typically at this moment in the PIC circuits, thermal phase shifters are used to compensate for this variability in manufacturing. But the thermal phase shifters, they bring some constraints also into the circuits themselves. They can increase, this is a heat mechanism, so the local heat might be very high, which usually degrades the reliability of the systems and comes with increased power consumption. And plus the TPS require calibrations. So the goal here is to find a way and present a way to tighten a bit the distribution. So what potentially what we would want is we want the fail regions to be depleted and bring all these circuit responses to the design wavelength. And this is what PIC trimming does. And it brings some benefits with it. It brings bringing fail circuits back to the pass where they can be shipped. So it has an impact on revenues, of course. And plus, when you're looking at the effect, the TPS will remain in the circuits, but they're used in a less stringent way. So the localized temperature would be lower, and then you would have higher reliability of these devices. So there's some key requirements. I'm going to cover 3 of them today. The linearity of the response. I want to just make sure that I mention that everything is tested in-house at our headquarters. We have a fully equipped application lab. So we tested 3 unbalanced Mach Zenders, and this is the response we get. So we have the normalized the response, which is variable, and after trimming we see that we can set the resonances to the target wavelength, and depending on the number of pulses that we use alongside the waveguide here, we get phase change that varies very, very linearly and extra attenuation that is very low. So linearity it's a key performance because it helps us to make quicker process in the end. Another key result is having a full pi shift. So we want to be able to recuperate all the different manufactured PICs and being able to shift the spectral response by a half period enables this. So we can do this and bring the spectral response to the desired wavelength. These are really nice key results, but you might want to know how permanent these shifts are. Basically, we've tested some of the devices that we have in-house that we've gotten from customers and that we've gotten from partners. And we've done some shifting of the spectral response by some radians and even a pi shift. And after 500 hours at 125 degrees, we get this very repeatable result. This is the difference between after the annealing test and before the annealing test. So if there were any movement at the pi shift level, we would have a very big variations. And since it's independent of the actual phase change, this is a very good result. Demonstrate permanency. And you see that the insertion loss also does not move. So what's our main product? How do we get this done? We have the laser source, which is rack mounted. It's fiber based, and we bring it to the optical head, which was newly developed. The optical head has a high precision focusing optics, so we can have very precise beam sizes. It's a 2D galvanometer, so we have beam pointing. The imagery is included. And this is all supported by an automation software, which controls the laser, the motioning stages, the vision, and the data management also. So we launched this product at OFC. You see here the fully integrated machine, and this is an example of our application lab. And while we're talking about the application lab, I want to be able to discuss briefly about how we work with the customers. So phase one, we have the phase one, which is evaluating and optimizing the process. The trimming process requires some optimization depending on the PIC circuit. We will have either phase, pulse width, pulse duration, pulse energy that we can tailor to get the optimized results. So we get these tests in before you actually buy the products. So this is a good proof of concept here that we work together. So quickly in summary, we have the PIC volume is integrating. We have the trimming performance, which is we can get pi shifts. It's a low loss solution, but there's also some other parameters that we can tailor. We can talk about this in details when we contact each other. So as a bonus, I'm putting trimming video links and other products that we have. And we should see each other in Munich also, which is a great opportunity for us to discuss. And if you have any questions, just contact me directly. So I want to thank EPIC and everybody for being here. It's a really nice opportunity for us to be here.
Right. Thank you very much, Robert. Great presentation. So please, raise your hands if you have any questions for Robert. And in the meantime, I was wondering, so what exactly will you display at the Laser World of Photonics? Will we see the whole process in operation?
It's going to be, we're going to be at the Canadian, with the Canadian Pavilion, and we will have some equipment and we will get some good idea about the capacity of what we're doing. We're always continuously doing some extra tests and extra demonstrations in-house. So we'll have more results. Actually, this is a very quick presentation for today.
Okay, nice. Well, looking forward to this. And indeed, it was a very impressive what you can offer for the PICs.
Yeah.
Okay, so if there's no further questions, I suggest that we close the meeting. Let me just share a couple of slides with you again. And we'll see you on the next occasion. So this was the EPIC members' new product release for you. We've heard of 5 actually speakers today, and I would like to thank them all again. So amazing advancements from Chilas, Coherent, Femtum, Delta Optical Thin Film, and Arden Photonics. Let me remind you that EPIC is there for you to help you with technology and market expertise, with marketing and networking opportunities, mentoring, recruitment, and investment. And let me thank my whole team, which made this meeting possible. And also, as we spoke so much about the Laser World of Photonics, don't forget that from 24th to 27th of June there, EPIC will be in charge of the integrated photonics application stage, which means we will have the stage with our EPIC members and the best, most exciting speakers of the whole community presenting their advancement and talking about the applications of PICs. So please join us there, and looking forward to see you soon. Thank you very much, everyone. The meeting is closed.
Thank you, everyone.
Have a great day.